students, welcome to our chemistry class. Our chapter name is Changes Around Us. In the last class, we started this chapter and discussed different types of changes. And we said that we can see different changes are there around us. And the thing is this, we studied changes are of two. Some changes are reversible and some changes are not reversible. Not reversible. And one thing is this, we can term this not reversible is irreversible. Irreversible. This we already mentioned in the last class. So we can say the changes are of two types, reversible changes and irreversible changes. That is, the changes which is possible to reverse is called reversible changes and the changes which is not possible to reverse is called irreversible changes. Different types of changes. And so we studied different examples for this. Which are the reversible changes? When we are folding a paper, it is a reversible change. Folding paper. The another example is when we are rolling the dough. It is also a type of reversible change. And what about the irreversible change? Which are the examples? Cutting of paper, cooking chapati, etc. are irreversible changes. So these are the things we discussed in the last class and now we are continuing the same topic. And so the first thing we are going to discuss is, do there occurs any other changes? Do there occurs any other changes? In the last class we said that shape can be changed by pressing or we can change by cutting, all the things we discussed. Here we are going to discuss another type of changes. And have you ever observed the tools that we are using to dig soil? Within our farm and all, we can see some sort of tools are there. Like it will have a wooden handle and a metal piece will be there. Some sort of tools. Different types of tools are there. So these tools have normally this will be wood and this is any type of metal, iron or something. This also iron and this also wood. And how this metal piece, how this iron piece is fixed on this wooden piece? How is it possible? We know when this iron piece is loose, then this tool is not at all properly used on our farm. So that the thing is this, to fix this tool on this wooden piece is very important. That must be very fixed or it must be very strong, very attached. So how we are fixing this wooden piece on this iron tool? How is it possible? Actually, the thing is this, here you can see one ring is there. Ring. That ring is actually little smaller than our wooden piece. Our wooden piece is bigger than this ring. Ring means some sort of ring is there for this tool. When you observe the tools in your home, you can see that. So the thing is this ring is small than this wooden piece. And now the question is this, how we are fixing this? Is it any method to make it big? We can make this small ring big by heating this. We can make this big by heating this. And you already studied in your 5th standard, when we are heating a particular substance, there occurs a change. What is that change? There occurs expansion. Expansion. So when we are heating a particular substance, not only this iron, whatever the substance, there occurs expansion. So the same thing happens for this ring also. This iron ring gets expanded. And so now this is bigger than our wooden piece, and so what happens? It is very easy to put this ring on our wooden piece. And now what happens after cooling? Still is this iron piece is big? No. After cooling, the expanded ring will convert to contraction. That means the big ring will get into smaller because of the cooling. So now what happens? Now this iron ring is fit on our wooden piece. This is how we are fitting the iron piece on the wood. Why we are saying all these things? Here you want to focus, the thing is this. You can see here the expansion and the contraction. This expansion is a type of change and this contraction is also a type of change. And now the question is this, we are heating this iron ring and it is expanded. And after cooling, it is contracted. Is it a reversible change or not? Is it reversible or irreversible? Actually, this example is reversible. The reason is this, at first our ring is small. And when we are heating, it is getting big. And after cooling, again it is back to the small size. So we can say the heating for this iron ring to expansion is what? Reversible change. This is a type of reversible change that is mentioned in your textbook. Just read it. And also the same thing you can see in the metal rim on wooden wheel. For the bullock cart and all, it have wheels. It have wheels. And the wheel is like this. So the wheel is like this, and on this wheel we want to fit one iron ring. Iron ring means on this wooden wheel we want to fit one iron ring. Same, this ring means a type of ring. And so you can see that picture on the page number 49 in your textbook, figure 6.7. Just look that. So here also we are doing the same thing. At first our iron ring is smaller than our wooden wheel, and we are heating this. When we are heating, what happens? Here also the expansion occurs. So now it can be fit on our wooden wheel, and then we will pour water on this hot ring. So what happens? Then the expansion will be go back to the contraction. That means the size of the ring will be go back to the initial state, and so that will be fit on our wooden ring. Here also the thing happens is the expansion and contraction. So you want to remember this expansion and contraction is a type of change, and in some cases that is reversible. In some cases it is not reversible. Here within your textbook they are mentioned about the activities which is reversible. So The next we are going to discuss about one activity. We are just taking a pan and taking some water in it. Within this pan we take water. And my aim is to heat this. What happens when the water gets heat? It starts boiling after some time. It starts boiling. And when I observe, I can see that the rate of water, the quantity of water is getting decreased. The quantity of water is getting decreased when we are continuously heating. Then the question is this, where this water is going? The water is converted to vapor. This water is converted to vapor. That means here this water is converted to vapor means it is also a type of change. We want to study is it a reversible or irreversible change. Is it reversible? So I am just taking a lid and collecting these vapors on this lid. And now what happens? I can convert this vapor to water after cooling. We already studied that in the chapter of separation of substances, that these vapors can be converted to water again after cooling. When I am placing some sort of ice cubes here, what happens? Now this is cooling. That means when our vapors start cooling, it will convert it to water again. There also a conversion, a change occurs. So the water will convert to vapor is a type of, is it reversible or irreversible? It is a reversible change. It is a simple reversible change. So we can say, this we can study for the conversion of ice to water, water to vapor, vapor to water, water to ice. All these type of changes are actually reversible change. That means ice. Here we have ice. When I am heating this, what happens? This ice will convert to water. And when again I am heating this, it will convert to gas or vapor. So, our ice, when I am heating this ice, it is converted to water. And here, when I am heating this water, it will convert to vapor. Now the question is this, is it reversible or not reversible? Irreversible. So, actually it is reversible. That means when this vapor is cooling, what happens? This vapor will convert it to water after cooling. And again when I cool this water, what happens? It will convert to ice. So we can say the conversion of ice to water, water to vapor, vapor to water, water to ice, all these things are reversible changes. All these are reversible changes. And so, I already said that when we are heating a substance, there occurs expansion. I already mentioned. And when we are cooling a substance, there occurs contraction. Here you can see the heating is there, cooling is there. Now, what about the expansion and contraction? Do there occurs expansion or contraction? What about this? That we are going to check. Do there occurs expansion or contraction? Very simple. That I am just taking within a beaker some ice cubes. And giving heat. So, after heating, what happens? Our ice melt to water. Ice melt to water. And when I am cooling this, convert to ice bag. Now the question is this, do there occurs expansion and contraction? Actually, for that we want to check the molecular arrangement of the atoms within this ice and water. So the thing is very simple. When I am taking a piece of ice, that means one ice cube, I can see the molecules are there. What about the molecular arrangement within the solid? We know that this ice is solid. So what about the molecular arrangement within this solid, this ice cube? They are very closely packed. You already studied this in your 5th standard. So this molecular arrangement is very closely packed. And what about the water? Is it still closely packed? No. For the water, the molecular arrangement is little more looser. Loosely packed. Loosely packed. That means when the ice is converted to water, that means when we are heating this ice cube to water, what happens? Here occurs expansion. There occurs expansion. That means you can see that these molecules are very closely packed. Here they are very near. It needs only small space. But when we are heating this, it is converted to water, and here the molecular arrangement is different. That means within the molecules they have more space in between. And so we can say when this ice cube is converted to water, there occurs expansion. There occurs expansion. So we can say on heating on the water itself, there occurs expansion. And ice, water, and again when we are heating, what happens? This will convert it to vapor. What about the molecular arrangement of vapor? They are very far. The molecules are very far. They are very loosely packed. So we can say here also the expansion occurs. Whenever we are heating, there occurs expansion. The molecules are getting far apart. So we can say it is expanding or expansion occurs. And again, when we are cooling this, what happens when we are cooling this? The molecular arrangement is getting near. That means they are getting contract. They are getting, the size is getting small. There occurs contraction. Contraction occurs. So for the water convert to ice also, there you can see the molecular arrangement is far. And when we are cooling this, what happens? It is there to closely packed, and so we can say there occurs contraction. So within heating there occurs expansion, and when we are cooling that, there occurs contraction. That is about this. And so now we are going to define the term expansion and contraction. Expansion. What is the definition for expansion? The increase in size of matter. The increase in size of matter by heating called expansion. The increase in size of matter by heating is called what? Expansion. Within the expansion, the space of molecules increases. Space of molecules increases. The space of molecules increases. So we can say the expansion is the increase in size of matter by heating. By heating, there occurs the increase in size. And here we can say the space of molecules are getting increased. So this is about expansion. And what about contraction? Contraction. The decrease of size of matter by cooling. The decrease of size of matter by cooling is called what? Contraction. The size is here decreases by what? By cooling. And here what happens to the molecules? The space of molecules space of molecules decreases. Space of molecules decreases. So this is the definition for expansion and contraction. Expansion, the increase in size of matter by heating. That is called what? Expansion. And there the molecular space is getting increased. And here the contraction, it is the decrease in size of matter by cooling. And here the space of molecules are getting decreased. So you want to remember this definition, expansion and contraction. And now, next we are going to study one activity, very simple activity. For that we need one candle. We are discussing about one activity that mentioned in your textbook, and for that we need one candle. Our lighting candle. So first we want to take the candle and measure the length using one scale. Suppose we are just taking the length of the candle. Before lighting this candle, suppose the length is 10 centimeter. I am just taking an assumption. And so, here I am going to light this candle. The same candle I am lighting. And now what you can observe? The wax start to melt. The wax start to melt. So you can see after some time our wax got melt. There the melted wax will be there and all. And now we are going to check the length of this candle. Again the same scale we are taking and look. Now is it the same 10 centimeter? No, you may get 8 centimeter, 7 centimeter or something. That means before heating our candle, the size was 10 centimeter, and after burning the size got changed and the length is got changed. So we can say this is also a type of change. We are always talking about the changes, and so we can say when the candle is got heated, there occurs a size change, size variation, and we can say that's a type of change. And so now the question is this: is it reversible or not? Is it reversible? That we are going to check. Again we are taking a pan. And taking some piece of wax here. Taking some pieces of wax, and I am going to give heat here. What happens? Do the wax will be the same tubes? No. We can see that the wax is getting melt. They got melt. Now I am removing the heat from the bottom, and now what happens? This wax are getting solidified again. That means it will get back to the solid state after the melting. So, is it possible to reverse? Yes. For the wax, we can say this is reversible change. The melting of wax, we can say that is a type of reversible change. It is possible to reverse because heating, our wax will get into liquid state. There occurs the change in state of matter. State of matter changes. That means the solid is converted to liquid for the wax when it is heated, and when we remove the heat, what happens? It normally turns back to the solid state from its liquid. So we can say it is reversible change for the melting of wax. And now we are repeating the activity using incense stick. Incense stick. Incense stick means chandanatiri. So we can say we just take this stick and burn this. stick is getting decreased. They are getting decreased. Their size is getting small. And you can see some sort of gas is produced here. That gas is having very pleasant smell. Somehow we can see that in some cases we are not possible to see, but we can feel the pleasant smell. So one thing, when this incense stick burns, its size changes, and also you can see at the bottom some sort of ashes are there falling down. The thing is this, our incense stick is converted to a new product here. The products are this gas, this pleasant smell gas, and also this ash and gas. That means here new products are formed. When we are melting the wax, do there any new products form? No, it's the same wax that is melting again back to solid. The new products are formed, but here we can see a new product. This ash is totally different from the initial instance. That means here at initial stage it is black in color, and after burning it will be in ash color, that ash. And also you can feel the presence of gas. And now my question is this, is it possible to turn back this ash and gas to our incense stick? No, it is not possible to reverse. So we can say some heating will cause to reversible change, but some heating won't possible to reverse. So this is one irreversible change. Irreversible change. This is a type of irreversible change, and for the wax it is reversible change. And also we can say the same thing for the match stick. We are burning this using a matchstick, no? So when we are burning this matchstick, what happens? This stick start burning, and is it possible to convert this matchstick back to the initial stage? No, we can say this is also a type of irreversible change. So generally we are saying that burning is irreversible change. That means burning paper, burning incense stick, burning matchstick, or anything, burning plastic, or whatever it is, the burning we are considering it as irreversible change. The reason is this, when burning happens, they produce new substances or new products, and it is not possible to turn back to the initial stage. And now we are going to discuss the last thing. We are always talking about the changes. When we are mixing two substances, what happens to that changes? Is it reversible or not reversible? That we are going to check. That means the mixing. Mixing of two substances. Mixing of two substances. Here I am just taking a beaker, filling it with water, and add some salt and dissolve it. So this is water plus salt. We already studied how to separate this water and salt. We know when we heat this mixture, what happens? The water will start to be vaporized and the salt will be left in this. That means after heating, we can separate this water and the salt will be there left in our beaker. So we can say this water and salt, when they are mixing together, is it reversible or irreversible? What is that? We can say when this water and salt is mixed, first they are mixing, a new solution produces, but after we can vaporize that and condensation, all things occurs, and we can say the water and salt, that will be turned back to the initial state. So we can say this is one type of reversible change when we are mixing two substances. Now the question is this, do all the times the mixing will possible to the reversible? And we are going to check using another activity. Just take a beaker and taking milk. We are just taking a beaker, filling it with milk. And now I am taking a spoon of curd. I am just taking a spoon of curd and adding this to this milk. So now our milk is what? Milk plus curd. Milk plus curd. I am just adding a spoon of curd in this milk and stirring it and keep it there. And after 2-3 hours, what we can see? This whole milk is now converted to curd. It is completely converted to curd. So we can say now this is a type of change. The question is this: is it reversible or irreversible? Here this is irreversible. That is, this curd is converted to milk. It is not possible. So we can say the conversion of milk to curd, the color changes or the type changes, the smell changes, the taste changes, everything is getting changed. That means this milk, when it is converted to curd, it is totally a new product and it is not possible to reverse. So we can say it is irreversible. So you just want to understand that here we are mixing two substances, one water and salt, here mixing milk and curd. So the thing is this: in some cases the mixing of substances will be reversible. In some cases the mixing of substances is irreversible. Both of the things will occur. So you just want to understand that within this chapter the main thing is this: you want to study which are the changes are reversible, which are the changes are irreversible. Basically within this chapter the aim is that. So finally our chapter is over. You just want to read your textbook 3-4 times and in the next class we can start the next chapter. And so you want to do the fourth question as the homework. Fourth question in the exercise part, page number 51. Just do it as homework, fourth one. So this is all about today's class. We will meet in the next class with the next chapter. Thank you.